Good morning, my dear students. So today I am going to teach you about. Today I am going to solve all the question of Intext question, and okay, it's 2.1 number question. Here we have to calculate mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Okay, we know that mass percentage equal mass of component divided by total mass into 100%. Okay, just see one thing, that here we have to write mass of component. Components means if it's solute or maybe it will be solvent. Okay, if we have to calculate mass percentage of solute, then we have to add like mass of solute, and if we have to calculate mass percentage of solvent, then you have written as like mass of solvent. Okay, so don't be confused that sometimes there is component, sometimes there is solute, sometimes there is solvent. Don't be confused about that. Okay, so now, okay, first of all, we have to calculate mass percentage of benzene. Mass percentage of benzene. So here, mass of benzene is 22 gram. 22 gram. Okay, 22 gram of benzene, and total mass is 22 gram of benzene, which is solute, plus 122 gram of CCl4, which is solvent, and the total is 144 gram. Okay, this is the total mass of solution. Remember that solution, which is consists of solute and solvent, and the total mass is 144 gram into 100%. Okay, so it will be around, let me check, it will be around 15.28%. 15.28%. Okay, now we have to calculate mass percentage of CCl4. And the mass of CCl4, which is a solvent, is 122 gram. And the total mass is 154 gram into 100%. So the answer will be around 84.72%. 84.72%. You can write these things as this, or yes, yes, another option, like we know that there's total solution percentage is equal 100%. Okay, there is 100% solution. If you get that there is 15.28% of solute, then we have to calculate the solvent. Okay, so solvent is like, if we subtract 15.28 from 100, then we got 84.72%. So in this way you also calculate. So it's depend on you which method you want to apply. Okay, so I'm going to the second number of question. It's quite easy comparing to others. So now I'm going to the second number of question, where the question is that calculate the mole fraction of benzene. Calculate the mole fraction. Calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. Okay, so we have to calculate the mole fraction of benzene. So we know that mole fraction is equal to, since we can take benzene as A and CCl4 as B. So if we have to calculate the mole fraction of benzene, only benzene. Okay, so we have to calculate XA. So in the above there is mole of benzene, and in the below there is mole of total. I mean total moles. Mole of benzene and CCl4. Okay, so now from here we know that there is 30. From 30% we know that there is 30 gram of solute, which is benzene, and there is 70 gram of solvent, which is CCl4. Okay, so now we have to calculate Na and Nb. That means mole of benzene, which is Na, and a mole of CCl4 which is Nb. Okay, so we know that formula is given mass by molar mass. Okay, so here given mass is 30 gram in case of benzene, and we have to calculate the molar mass, and in the case of CCl4 the given mass is 70 gram. Okay, so we have to calculate the molar mass. Molar mass of benzene is around 6 into 12 plus 1 into 6. I write it differently, maybe you feel confusion. So 12 into 6, because the molar mass of carbon is 12 and the molar mass of hydrogen is 1, and it's around 72 plus 6, 78 gram per mole inverse. This is for benzene, gram per mole inverse. And for CCl4 it's 12 plus chlorine have mass around 35.5 into 4, so it will be around 142, so 154 gram per mole inverse. 154 gram per mole inverse. If we calculate these two value, we get it around 385 and 455. 0.35 mole and 0.455 mole. So we have the value of Na and Nb. We just put this in this equation, and in this way we can calculate our, we solve our problem. Okay, now I am going to put these two value in our equation. Maybe you all you can do that by yourself. Mole divided by 385 mole plus 455 mole. Okay, so in this after this calculation we get the value is around 458 mole. See, you don't have to calculate the mole fraction of CCl4. If examiner want that you have to calculate the mole fraction of CCl4, which is XPL, so then what you can do, you just subtract this value from 1, and in this way you get the value of XPL. So okay, because we know that XA plus XP equal 1. See, it's not X actually. I usually use it as X, but it's not X. It's the symbol for mole fraction, but it seems like X. That's why I tell it X as X in many times. So sorry for that. And okay, and now I am going to question number 2.3. In 2.3, what we have, let me see, is calculate the molarity of each of the following. Calculate the molarity of each of the following. In first, in A, we have 30 gram of cobalt nitrate, 6H2O, 6 hydrated in 4.3 liter of solution. Okay, and in the second one it will be 30 ml of 0.4 m H2SO4 diluted to 500 ml. 500 ml. Okay, so now I have to calculate the question number 1, I mean A, in of 2.3. Here we have to calculate molarity. Okay, so we know that molarity equal number of moles of solute divided by volume of volume of solution in liter. Okay, so for that we know about volume of solution. It's 4.3 liter and it's already in liter, so no need for transformation. And here we have to calculate the moles of solute. Okay, so for calculating moles of, here solute is cobalt nitrate 6H2O. We have to know about given mass by molar mass. So given mass is around 30 gram. Now we have to calculate that molar mass of it. Okay, for cobalt it's cobalt. Okay, for cobalt its molar mass is 59. It's not carbon and oxygen, please remember that. And then for nitrogen it's 14 into 16 into 3 for 3 oxygen, and there is whole 2, so you have to keep this thing in bracket and then multiply by 2 plus 6 into, for H2O we know that for H2 its molar mass is 18. Okay, so if we calculate this, then its value around 291 gram per mole inverse. So 291 gram per mole inverse. If we calculate it, then we get the value is 0.103 mole. Okay, then just put this value in this equation. Molarity, the mole is 0.103 mole and volume is 4.3 liter. So we get the answer is in mole per liter. The answer is 0.24 mole per liter. Please do this calculation by yourself, because don't know, maybe I have done mistake in my calculation. So if it's mole per liter, so its unit is molarity. Okay, so we calculate the question number A. Now we are going to question number B. Okay, question number B is quite interesting. Here tell that 30 ml of 0.5 molar H2SO were diluted to 500 ml. Okay, since okay, let me give you an example of your practical examination. Okay, your examiner make 0.5 ml, sorry, 0.5 molar H2SO4 solution. Okay, and he give you 30 ml of it. Okay, and then he tell that make it 500 ml. If you have to make that 30 ml to 500 ml, so you have to add 470 ml water to it. Okay, so this thing that if you add 470 ml water in this 30 ml of solution, then molarity will be changed, right? Molarity will definitely be changed. Okay, but you have to remember one thing, that after dilution also number of moles of solute doesn't change. Sorry for my English, I am very weak in grammar. Doesn't change. Okay, so after dilution also number of moles of solute doesn't change. So okay, let me just okay, first of all, before dilution number of moles before dilution equal number of moles after dilution. Okay, let's just assume that before dilution your molarity is M1, your number of moles of solute is N1, and your volume is in Q1. Okay, and after dilution do this dilution, then your molarity is in M2, your number of solute is in N2, and your volume is in V2. Okay, so it will be like N1 equal M1 V1 and N2 equal M2 V2. And we know that number of moles, that means this N is N denote number of mole, and V denote volume, and M denote molarity. Okay, number of mole before dilution is equal to number of moles after dilution. Okay, so before dilution it's N1 equal N2, right? That means we can write as M1 V1 equal M2 V2. We get this expression, which is really very important. In practical, maybe you get this, but now from today you learn that how you know how you get this equation from where. Okay, this is, I get this equation from molarity. Okay, so now I'm going to put the values here. The M1 before dilution, molarity is 4.5 molar before dilution, volume is 30 ml. After dilution, volume is 500 ml, and we have to calculate that M2, I mean that molarity after dilution. Okay, so after dilution we get molarity as 0.5 molar into 30 ml divided by 500 ml. So its value is around 0.03 m. That's it. Okay, now I am going to the question number 2.4, which is really very important for you all because it's quite tricky. First of all, you don't feel like that you can do that because it's quite tricky, but just try to learn this question more and more, and just I told you everyone before also that just concentrate on that question, that what examiner want to ask. Okay, so in 2.4 we have to calculate the mass of urea. Calculate the mass of urea, NH2CO, NH2. Calculate the mass of urea required in making 2.5 kg of 500 of 0.25 molal aqueous solution. Aqueous solution. It's really very important question. Just now, just watch the question very clearly. I mean, just try that what given in this question. There is some mass of the whole solution. Then they tell us about the molarity. Okay, now I'm giving you that first. It's 2.25 molar. Molar means molality. Okay, if it's molar, then it means molarity. Okay, molality means M, and molarity means capital M. Okay, and in molal we have definition like number of moles of solute divided by weight of solvent, not solute, solution. Okay, remember that it's solvent weight in kg, and in molarity it's moles of solute, number of moles of solute divided by volume in liter. Okay, now let me give you an example of that. It's depend on molarity, depend on temperature, but molarity doesn't depend on temperature. These things is in your book, you just check. Now I'm going to tell you that why this is happened. See, we know that if we increase the temperature or decrease the temperature, then volume will also change. Okay, but if we increase or decrease the temperature, I mean if you change the temperature, then also your weight is remain the same. Okay, so if you prepare, let just in your laboratory today is there's temperature is 25 degrees Celsius. You prepared a solution of 2 molarity. Okay, and you also prepare the solution of 0.2 molarity. Okay. Let's say in the next day, whereas the temperature is 45 degrees C, then it remain the same because it doesn't depend on temperature, but the molarity will be changed. It's not the actual, because your volume is changed, so your molarity is also changed because volume depend on temperature. That's right. Okay, this is just for general knowledge. This type of question are regularly asked in your examination, so I tell you about this. Okay, so from 0.25 molar, what we know about that? From this thing, we know about that there is number of moles divided by weight of solvent in kg. From here, we know that 0.25 moles of solute present in 1 kg of solvent. Is it correct? See, this here's 0.25 molar. That means number of moles of solute divided by weight of solvent. See, if I divide 2.5 moles per kg of solvent, then we get 5 mole per kg. Mole per kg means m. That means mole. So from this we know about this. That means 0.25 mole present in 1 kg of solution. Okay. So what is the solute here? Here solute is urea. Okay. So molar mass of urea is 14 plus 1 into 2 plus 12 plus 16 plus 14 plus 1 into 2. You have to remember these things. Must be, you have to know these things. Okay. 14 plus 2 plus 12 plus 16 plus 15 plus 2. It's around 4, 20, then 24, 28. It's around 60 gram mole inverse. Okay. So we know about that molar mass of urea. So from this we can calculate, like we know that number of moles of urea, that means solute, equal, we know that given mass by molar mass. Okay. So here in this question, this given mass is not given. Okay. So you should also, like it says, it's solute mass. Okay, you should like it as solute mass. I remember that formula, like given mass by molar mass. It's very useful for me. That's why I remember that. Okay, so here moles of urea is already given, which is this one 25 mole, and molar mass we got from here, it's 60 gram per mole inverse. So from this equation we came to know about the exact mass of solute. Okay, so solute mass means mass of urea, right? Because here solute is urea. Mass of urea equal 0.25 into 60 gram. So mole is cancelled out, so we get it's 15 gram. Okay, so from this we came to know about the mass of urea. So we got the mass of solute. The mass of solvent is also known so mass of solution equal mass of solute plus mass of solvent. Okay, mass of solute plus mass of solvent. Mass of solute is around 15 gram and mass of solvent is 1 kg. We should convert it to gram, then it will be easy, 1015 gram. Okay, so we calculate the mass of solution. Here asks that if you require to make 2.5 kg solution, then how much urea you need. Okay, here we can write as like that. If we want to make 1015 gram solution, then solution need urea how much? 15 gram. So if you want to make 2.5 kg, you just convert 2.5 kg into gram. 2.5 into 1000 gram means 2500 gram. Okay, so if you want to make 1 gram, then it will need 15 by 1015 gram. But if you want to make 2500 gram, that means 2.5 kg, then you need 15 by 1015 into 2500 gram, then it will be around 57 gram. So that's it all about this question. Now I am going to question number 2.5, which is the last question, and it's quite tricky, but you just practice a lot, then you can also do that very well. I mean very easily. Okay, now it's time for the last question, and then today's class is over. Okay, in 2.5 we have calculate molarity to molarity, 3 mole fraction. Please ignore my handwriting, I have to work on it a lot. It's not that bad in copy, but don't know why in board my handwriting is too bad. Please ignore this, okay? Of Ki, if the density of 20% mass equals Ki I'm introducing my right to 1.202 intersection gram and dash. Okay. So okay, now let me tell you one thing, that I already complete this equation. I mean I already solved this equation. I mean I already calculate this mole fraction in my first video. You should check this. Okay, so now we have to calculate the molarity. We know that molarity equal number of moles of solute divided by weight of solvent in kg. Okay, yeah, here the solute is Ki, and here 20% is also given. So from 20% we came to know about that there is 20 gram solute plus 80 gram solvent equal 100 gram solution. Okay, from 20% we came to know about that. We already practiced those things already. Okay, so molarity, and we came to know about this solvent in kg. Wait, it's in gram. We have to transfer it in kg. I mean gram, just divide by 1000 and it's converted to kg. Now we have to calculate the number of moles of solute. That means Ki mole. Okay, weight of Ki is 20 gram. That means given mass by molar mass. We already know about that, 20 gram, and we have to calculate the molar mass of Ki. So molar mass of K is 39.10 and I is 126.90. You should also like that 39 plus 127. This is also correct. So it's 126 gram per mole in dash. 166 gram per mole in dash. So if we calculate this, it's around 1.2 mole and it's around 0.080 kg. So the answer is 1.51 m, 1.51 mole per kg. That means 1.51 mole. Okay. So after that I have to calculate molarity, which is moles of solute in the above and in the below, volume of solution in liter. Okay, so it remains same. I have to change this one. Okay, we don't here volume of solution is not given, but here density is given, and from density we can calculate, like we know that density of solution equal mass of solution divided by volume of solution. You already know about that density equal mass by volume. We need volume of solution. Volume of solution. So it's equal mass of solution divided by density of solution. Mass of solutions means total mass. Mass of solute plus mass of solvent, and it's around 100 gram. Okay, we know that 20 gram is solute, 80 gram is solvent, so mass of solution is 100 gram, and density of solution is 1.202 gram ml inverse. Okay, so the answer is around HP1 liter 0.0831 2 liter. 2 liter. Now we have to put this in here. We have to put this volume 0.832 liter, 0.832 liter, and the answer is around 1.44 mole per liter. Mole per liter means 1.44 molar. Okay, so this is come to end of this video. Yeah, you should check this mole fraction in my previous video, which is my first video. I mean the part 1 video of this chapter, solution chapter. So yeah, if you don't want to check, then I just tell you that yeah, if we have to calculate mole fraction of Ki only, so Ki take as A, so it will be like Xa equal number of mole of Ki, and in the below number of total mole, that means Na and Nbn. Here the solvent is water, because we don't see any else, so it's let this is as water. So we know that Ki have weight 20 gram and solvent have weight 80 gram, I mean H2O. Okay, so it will be around 20 divided by 166, and its value is 10 divided by 166, and for Nb it's 80 divided by 80 gram given mass, and the molar mass is 15 gram. If you calculate this, then it is around 0.0263. Okay, and here we don't need to calculate the mole fraction of water, but if examiner want to know about that what is the mole fraction of water, then you just subtract this Xa from 1, because we know that Xa plus Xp equal 1. We already learned these things in our previous video. So that's it all about today's video. It already taken lots of time, and please take care a lot, stay home, stay safe, and study a lot. Please you have to remember this mole fraction, molarity very well. You learn it very well. You just practice it a lot. You just think like that exam is very soon. You just practice these things very well, and it will be reminded for you. I mean, you never forget that if you practice this very well. Okay, that's it for today, and take care a lot, and yeah, thank you so much for watching.